This is the lesson for 1-3. We're going to talk today about parts of an expression. Okay, first we have some vocabulary. So the first is, what is an expression? An expression is different than an equation. An expression is a mathematical phrase, so not a sentence, just a phrase, and it can contain numbers, variables, and operations. So some examples of this: an expression could be something like 4x squared minus x plus 7. That's one expression. Another example could be 7m to the third. That's one expression. And another example could be negative 5m n to the third plus 1. That's another expression. So I have three expressions there. You'll notice that they have different letters or different exponents or different numbers of terms. And term is the next thing that we're going to talk about. So a term is a single number, variable, or it could be a combination. One or more terms that are joined by addition or subtraction would make an expression. So when you have addition and subtraction, then that takes us from one term to the other term. So an example of one term would be 8. That's one term. Another example of one term would be 6v to the fourth. That is one term. Another example of one term would be 4h over 9. That is one term. As long as you only have multiplication and division, you are only talking about one term. And another example would be y. So then if I was to say, okay, don't write this down on your paper, but if I was to say, that, now all of a sudden I have an expression of 4 terms. Okay, so that's what makes the difference between an expression versus a term. So when you throw addition or subtraction in there, that makes it a combination of terms. Okay, the next thing that we need to talk about are like terms, and you've talked about this in previous years. Okay, so terms that have the same variable raised to the same power. So in other words, the variable parts must match, and that has to be an exact match. Okay, so if the variable parts match exactly, then you are talking about like terms. But if the variable parts have any different, like m to the third or m to the second, then they don't match exactly, and so they would not be like terms. We have to know about like terms because if we're adding or subtracting terms, they have to be like terms in order to add or subtract. Now for multiplying or dividing, we don't have to worry about like terms. Here are some examples of like terms. If I had 6cd to the fourth and 8cd to the fourth. Those are like terms, so I could add them or I could subtract them. Another example of like terms would be 8f and negative 15f. Notice that the variable parts are what matches exactly. And another example of like terms would be 11r to the second and r to the second. So I could add those or subtract them. Now you do not have to have like terms to multiply or divide. That's different. Okay, the next one we're going to talk about is coefficients. So coefficient is the number part, the numeral part, in a term with a variable. So if I have, for example, if I have 6cd to the fourth, then 6 is the coefficient. So you need to know what these words are, because if I say the coefficient, you need to know what we're talking about. And so another example is if I say r to the second, then 1 is the coefficient, because that's the number that's in front of the r to the second power. Okay, and then last is a constant. And a constant is something that doesn't change. Now when you have a variable by, essence of the word, it means that it changes. So a constant is something that doesn't change. So it's a number that does not have a variable. So an example of a constant would be 8 or negative 17. Or 0. Those are all constants because 8 is 8 no matter what. Now if you say 8x, then all of a sudden it depends on what x is. But if you just have 8, that's a constant. So we're going to practice using these words in the next section. It says for each expression, question number 1, can the expression be simplified? So if it can be simplified, then that means that you have to add like terms or subtract like terms or multiply what needs to be multiplied or whatever there is to do. And if it can, then simplify, and then you're going to do step 2. If you can't simplify it, then just do step 2. Step 2 is identify each term, coefficient, and constants. So question number 1, it says 10b to the third minus 10b. So can it be simplified? So what I have to look at is I have to look at, do these variable parts match exactly? Now they're both v's, but I've got a v to the third and v to the first. They do not match exactly, so they can't be simplified. So I'm going to go on to step 2. So what are the terms? So I've got one term and I've got another term. Now this sign right there, that goes with the term. So my terms are 10v to the third and negative 7v. Two terms. The coefficients, those are the number parts, so it's going to be 10 and negative 7. The constant would be any number that I have with no variable there, and there aren't any, so I'm actually going to just say none because there are no constants. Okay, let's go to number 2. Number 2, that has a lot of stuff going on, and so the first question, can it be simplified? We actually can simplify a lot here. So what we're going to do is we're going to use our skills from previous years. We're going to use the distributive property first. So I'm going to do 2 times 3, and then 2 times x. And then it says plus x times 1, and then x times negative 4x. So a positive times a negative, 4 times x is x to the second power, and then plus 5. But I'm not done yet, because now I'm going to look for like terms. So negative 4x to the second power, I'm going to write that first, and it does not have anything else that's x to the second power. What about the 2x and the 1x? That will give me 3x. And then I've got 6 and 5. Okay, this is the expression that I'm going to use to answer the following questions. So the first question, what are the terms? You would say negative 4x squared is one term, 3x is another term, and 11 is another term. The coefficients are negative 4 and 3. 11 is not a coefficient because in order to be a coefficient it would have to have a variable, but 11 is a constant. So you might need to examine that example a little more closely, but you have to first simplify it before you can answer these questions. Okay, number 3. Can you simplify it? So you're going to look for like terms or anything that you can do. So I see 9n minus 8n. Make sure you pay attention to that sign. So if I have 9n and I take away 8n, I have 1n. And then I have 12 minus 7, that's plus 5. So that's what I'm going to use to answer the question. So the terms are n and 5. The coefficient, look for the variable. What's in front of the variable? What's in front of that variable right there? It's a 1. 5 is not a coefficient because there's no variable. So 5 is a constant. Okay, next example, number 4. This is one term and this is another term. They are not like terms because this one does not have an x to the second power. So they're not like terms, so I cannot simplify it anymore. So I'm just going to say the terms are 3x to the second power over 4 and 5. Let's come back to the coefficient one in just a second. Can you tell me what the constant is? It's 5 because that has no variable. Now for the coefficient, this one's a little bit harder because people have a harder time seeing this. If you have 3x to the second over 4, that is the same thing as 3/4 x to the second. So if I write it this way, can you see what the coefficient is? One skill that you will hopefully develop in math is you'll be able to see different ways to write things. We're going to talk a lot this year about different perspectives and seeing things in different ways. And so to see that these two mean the same thing, that's going to be really helpful to you moving forward. Okay, number 5. Is the expression 6m minus 10 equal to the expression 2 times 3m minus 5? And so in order to answer that question, I would have to simplify that right there and see if it's the same thing. So 2 times 3m, that means I've got 3m and 3m. I've got two of them, so that's 6m. And 2 times negative 5, that's negative 10. Is that the same thing? Yes. And so the easy part of this question is to say yes. The explain your answer, that requires a little bit more thought. So how would you explain your answer? How did I come up with this? What property did I use? And so what I'm going to say, and you can go ahead and write this down, but you're going to have to be able to explain things like this yourself. I'm going to say using the distributive property, these expressions are equal. That's how, because of the distributive property. So if you've, in the last two assignments where you've thought about why you're doing things to each side of the equation and what your steps are and what your justifications are, when you start thinking about that, then it becomes a lot easier to explain what you're doing. Okay, number 6, is the expression 12v equal to the expression 7v plus 5? So pause the video and write either yes or no and explain why you think or why you don't think. Okay, so what I'm doing with this one is I'm looking at this expression 7v plus 5 and I'm wondering, can I do anything with that? And so I have to look at the terms. Are these like terms? They're not. So because they're not, it's like if you have a cookie and a banana and you put it together, you still have a cookie and a banana. You don't have something mushed together. And so I can't combine those. They're not like terms. And so that makes this the answer no. And so I'm going to say 7v and 5 are not like terms. Now you didn't, of course, have to say this word for word, but you should say something about the fact that because they weren't like terms, they're not equal to 12v. Okay, let's go to number 7. Is the expression 12v equal to, and then I've got 7 plus 5 in parentheses times v. So pause the video and write down what you think. So for this one, I'm looking at the 7 plus 5, and I notice that that's in parentheses, and so I think back to, well, what does that mean? Well, that means order of operations says I have to do what's in there. So 7 plus 5 is 12. And so I'm going to take 12 times v. I do not have to have like terms to multiply, so that's equal to 12v. So are they equal? Yes. And the reason why is because what we were able to do there. It's order of operations. So we're going to say yes, order of operations allows us to simplify this. Okay, number 8. This one's kind of a harder one. You're going to see this a couple times this year as we talk about different types of equations and expressions. But this is an important one to understand. So is the expression 4 times 3 to the x equal to 12 to the x power? So I want you to think about that and think about why you would explain it the way you're going to explain it. Okay, one way that you could think about this, because this is one that maybe you just really do not know. One thing you could do is just pick a number. Let's keep it small, but let's just pick a number. Let's just say I'm going to let x equal to 2, and you could have picked anything you wanted. So if I put 2 in for x right there and 2 in for x right there, if they're the same expression, I should end up with the same thing. So if I have 4 times 3 to the second power, that's 4 times 9, which is 36. And then if I do 12 to the second power, I have 144. Well, anybody can see that those are not the same thing, so they're not the same expression. So that's one way that you could explain it. In math, when you're explaining your answer, it doesn't always involve words. Sometimes it can you can just show your steps, and so that would be a reasonable explanation. Okay, another thing that you could say or think about is that when you're looking at 4 times 3 to the x, this is an exponent and this is multiplication. If you think back to your order of operations when we talked about GMDAS, what comes first? The exponents come before multiplication does. And so 3 to the x power, I cannot say, well, I'm going to do 4 times 3 first and then I'll raise it to the x power. It doesn't work like that. So really, this comes down to an order of operations. Okay, so really it's because of order of operations. Okay, so that's one way you could explain it. Or like I said, you could say if x is equal to 2, then 4 times 3 to the second power, which is 36, is not equal to 12 to the second power, which is 144. That's also an explanation, so you could do either one of those. Okay, next one is the expression w plus 0.25w equal to 1.25w? So pause it and think about your answer and write down what you think. Okay, since this is addition, I need like terms. Do I have like terms? Well, I have w and w. So I do have like terms. So in order to add, I take the coefficient from this and I add it to the coefficient of that. So I'm going to do 1 plus 0.25. That's 1.25. And so that's going to be 1.25W, because if I have 1W and 0.25W, I have 1.25W. Think about it like this. If you have $1 plus $0.25, you have $1.25, $1.25. And so that's what we're doing here. So you can say yes, and you can say like terms. So we can add. Okay, so it's because of like terms, that's why you can do that.